Now that we've seen how sand grains adjust themselves on a slope to give the angle of repose, let's look at a slightly different experiment. And what we have here is a plane. Behind it is a protractor, so you can keep track of the angle. And here we have a block. And the question is, what will happen to this block as we increase the angle on the plane? So let's start out, and we begin to increase the angle. You can see we're up about 10 degrees, up about 20 degrees, up about, oh, we get a little motion, and there we are at about 32 or 33 degrees. Wow, that's pretty close to what we got for the angle of repose. Let's flip the block over and see if we get the same answer on the other side of the block. So the frictional contact may be just a little bit different here. So the angle goes up and up and up and up. We're up to about 20 degrees, and oh, there it goes. So that time it was more like 27 or so. So that gives you some feeling for the reproducibility of the experiment. You can see the angle of repose does depend a bit on the frictional contact between the objects that are either sitting on the plane or below the plane. Here we have a very smooth surface compared to the sand grains, and a pretty smooth surface on the block. So that will give you a little bit of a feeling for what might go on. Now we're going to do another experiment, which is highly sophisticated, and what I want to do is to pose this so that it's very close to the angle of repose. So right now we're, say, somewhere around 25 degrees. Okay, now one of the important things is that landslides can be triggered by other activities. For example, by earthquakes. So here comes a band of seismic waves. And as you can see, it clearly caused movement of that down the slope, and of course it also knocked apart the rest of the experiment. The key point to carry away from this little demo is that shaking can trigger landslides to occur if they're close to their critical angle. So let's wind up this video